Hello students, this is lecture number 1 on differential equations, and in this lecture we will study the definition of the differential equation, what means order of the differential equation and solution of the differential equation. Now firstly, before learning what means differential equation, you must be familiar with the simple equations like linear equation. Okay, linear equation means what? The equation whose degree is 1, it's called the linear equation. Okay, this is also called the degree 1 equation. Degree 1 equation. Okay, for example, ax plus by is equal to some constant. This is the linear equation. Okay, where this a and b are constants and this x and y are variables, and c is also constant. C, A, B are constants. Okay, we also know what means the quadratic equation. Okay, quadratic. So quadratic, in general, we write the quadratic equation as ax square plus bx plus c is equal to 0. Okay, also we know the cubic equation or degree 3 equation. Okay, in general we write this as ax cube plus bx square plus cx plus d is equal to 0. Okay, so in this the degree of this equation is 1, in this the degree of this equation is 2, and in this the degree of this equation is 3, so that we can find the degree of equation n. Okay, and also we can find the solution of any linear equation or quadratic equation or degree 3 equation or degree n equation. Okay, now we will see what means the differential equation. Okay, so differential equation, we'll write the definition. Differential equations. Okay, so this is also the equation, this is also the equations, but it contains one extra term, that is the differential coefficient. Okay, so it is an equation, and equation which involves differential coefficients. Differential coefficients, it's called differential equation. Differential equation. Okay, so an equation which involves differential coefficient is called the differential equation. Now question is, what are the differential coefficients? Okay, so differential coefficients are of any order. Okay, for example, I will say this equation as differential equation. Okay, because it involves this differential coefficient dy by dx. Okay, also I can call this equation dy by dx square, d2y by dx square plus sin x is equal to 0. This is also the differential equation because again this involves this differential coefficient. Okay, and so on. Okay, so this is called differential equation. Okay, now thing is, what means order of the differential equation and the degree of the differential equation. Okay, so firstly we will see the order of the differential equation. Order of differential equation. Order of differential equation. Okay, so basically the question they may ask you, find the order and the degree of the differential equation. So the definition will work here. So order of the differential equation is nothing but it is the highest ordered derivative involved in that differential equation. That will be the order. Okay, so what is the definition? Highest ordered derivative, it is what? Order of highest order derivative. Okay, I will write it like this. It is order of highest ordered derivative. Order of highest ordered derivative is called order of differential equation. Okay, now for example, suppose I will take this differential equation dy by dx is equal to 0. Okay, where y is a function of x. Now if you observe here, what is the highest order derivative involved in this differential equation? Okay, so this dy by dx is the highest ordered derivative. Okay, so dy by dx is the highest order derivative and its order is 1. So the order of this differential equation is 1. Order will be equal to 1. Okay, for example, suppose second example, I will take this as d2y by dx square plus y plus some sin x is equal to 0. Okay, then question is find the order of this differential equation. Now again, obviously the highest order derivative involved is d2y by dx square and its order is 2. So order of this whole differential equation is 2. Okay, third example, suppose I will take this as d3y by dx cube plus d2y by dx square plus dy by dx is equal to 0. Again, obviously the highest ordered derivative involved is d3y by dx cube, so order of this differential equation will be 3. Okay, I hope it is clear now. Now next thing is we will see what means degree of differential equation. Okay, so we will see what means degree of the differential equation. Now the degree is nothing but it is a power of highest ordered derivative, power of highest ordered derivative in differential equation. But which differential equation? Which is free from radicals and fractions. Okay, which is free from radicals and fractions. Okay, so firstly, most important thing is our differential equation should be in the simpler form. Okay, so this is the definition for the degree of the differential equation. Okay, for example, I will take this as d2y by dx square plus y is equal to cos x. This is our differential equation and the question is find the degree of this differential equation. Okay, to find the degree for this differential equation, what we do, what is the definition? It is a power of highest ordered derivative. Now firstly you need to identify what is the highest order derivative involved in this differential equation, and that is what d2y by dx square. So this is the highest order derivative involved in this differential equation and its power is 1. Okay, so that therefore the degree of this differential equation will be equal to 1. Okay, now we studied what means the order of the differential equation, also the degree of the differential equation. Okay, we will see some examples for this. Okay, so suppose example number 1. Okay, firstly I will write the question, find order and degree of differential equation. Okay, so first example is suppose what is the order and degree of this differential equation. So this is d2y by dx square plus dy by dx plus y is equal to some constant c. Okay, so by the definition of the order of differential equation, what is the highest order derivative, is d2y by dx square. Okay, so order of this differential equation will be 2, and what is the power of d2y by dx square, that is what, 1. So degree of this differential equation is equal to 1. Okay, second example, if you will see, what will be order of this differential equation. Suppose I will take this as d3y by dx cube plus d plus 1 is equal to some constant c. Okay, so question is, what will be the order and degree of this differential equation. Okay, so in the definition of degree of the differential equation, we have seen whatever differential equation we have, it should be free from radicals and fractions. What means radicals and fraction? Means what? It should not contains the differential raised to 1 by n type terms. Okay, and fractions means what? The differential equation should not be in this form, p by q form. Okay, so if you will see this example number 2, it contains the term like raised to half. Okay, so I can write this as a d3y by dx cube plus 1 raised to half. Okay, is equal to c. So it contains the radicals like this. Okay, so it should be free from that. Okay, so to remove that, what we will do, we will square on both sides. Okay, therefore squaring on both sides, so what we will get, this will be d3y by dx cube plus 1 is equal to c square. Now this is our differential equation, which is in the simpler form. It does not contain any radical, any fraction. Okay, now we can check the order and degree of this differential equation. So order of this differential equation will be 3, because highest derivative involved in this differential equation is 3. So order will be 3, and the degree of third order derivative in this differential equation is 1. So its degree will be equal to 1. Okay, suppose we take one more example. Okay, suppose this is d3y by dx cube, okay, raised to 2. Then suppose d4y by dx raised to 4 is equal to 0. Okay, question is, find the order and the degree of this differential equation. Okay, so what is order? Okay, what is order? Order is the highest ordered derivative. Okay, so what is highest order derivative? d4y by dx raised to 4. So order will be 4. Okay, and what is degree? Degree will be the power of highest order derivative. So this is highest order derivative and its power is 1. Okay, so the degree of this differential equation will be equal to 1. Okay, so that's it. Okay, I'll see the one more example. Example number 4. Okay, so this is d2y by dx square plus y is equal to some constant c upon dy by dx. Okay, now question is, what is the order and the degree of such a differential equation? Okay, so it should be free from radicals and fractions. Okay, so what we will do, okay, I will change the example. Okay, c, this is raised to, suppose 2, okay, and this is suppose some constant is equal to some constant only, c. Okay, so check the order and the degree of this differential equation. Okay, so firstly this is to the power 2. Okay, so what will be order? Okay, so to check the order for this differential equation, what we do, we basically check the highest order derivative. Okay, so we need to simplify it first, our differential equation. Okay, so while simplifying, this is like a plus b whole square, that is a square plus b square plus twice ab. So this will be d2y by dx square plus y square plus 2y into d2y by dx square is equal to constant. Okay, now you can check what is the highest ordered derivative, which is this one. Okay, and its power is 2, so order of this differential equation is 2 and the degree of this differential equation is 1. Okay, now after understanding what means the degree of the differential equation and the order of the differential equation, we will go for what means the solution of differential equation. Okay, so before studying what means solution, okay, so what we will start with solution of differential equation. Okay, so before starting what means solution of the differential equation, you must know what means solution. Okay, so what is solution? Okay, so suppose I will take any linear equation like 3x plus 2 is equal to 0. Okay, so we know what we will get. We will get the solution for this x is equal to minus 2 by 3. We will say this value for x is a solution of this equation, because why? Because if you will put the value for this x into this equation, the equation will get satisfied. Okay, so this will be 3 into, put the x is equal to minus 2 by 3 plus 2. Okay, so what will happen? This will be equal to 0. Means what has happened? If you will put the value for this x inside this equation, the equation got satisfied. This means what? This means what? X equal to minus 2 by 3 is a solution. Right? It is also called the root of that differential equation. Okay, suppose we'll take one more example like x square plus 5x plus 6 equal to 0. I took the degree 2 equation. Okay, so we can simplify this as x plus 3 and x plus 2 is equal to 0. Okay, so we will get the value for x, that is minus 3 and minus 2. Okay, so again the values for x which are minus 3 and minus 2 will be solution for this differential equation. Means what? The value for the variable x, that is minus 3 and minus 2, will satisfy this equation. Okay, that is why we call this as solution or the root of that quadratic equation. Okay, so from this we can form the definition for solution of equation. Okay, so what is solution of the equation? It is what? It is value for the variables, which satisfies the given equation. Okay, for example, if I will take x square minus 1 equal to 0, okay, so if I will put x is equal to 1, see what will happen? X square minus 1 will be equal to 0. This means what? X equal to 1 is the solution of this equation x square minus 1. Okay, hope it is clear now. Also we can check it for x equal to minus 1 also. X equal to minus 1 is also the solution for this this equation. Okay, but now after understanding what means solution of the equation, our actual interest is in what means the solution of the differential equation. Okay, so we will write it here. It is what? Solution of differential equation. Okay, so basically the solution of differential equation, the definition is it is the relation between dependent and independent variable. Dependent and independent variable which satisfies given differential equation. Okay, so this is the definition for the solution of the differential equation. So what they are saying, it is a relation between dependent and independent variable. Okay, so suppose we have any function of y as a function of x. Okay, so in this case this y is called dependent variable. Okay, because it is depend on x, that's why it will be dependent variable, and this x is called independent variable. Okay, so basically what means solution? The solution will be, in this case it will be the relation between this y and x which will satisfy our given differential equation. That's when we will call this as the solution of that particular differential equation. Okay, for example, suppose I'll take one differential equation like d2y by dx square plus y is equal to 0. Okay, now see, if I will take, suppose in first case, suppose if I will take y equal to sin x. Okay, now what is the order of this differential equation? Order of this differential equation is 2 and the degree of this differential equation is 1. Okay, and suppose I will take this function y equal to sin x. Okay, and if I will differentiate this y 2 times, why 2 times? Because the order is 2. Okay, so if I will differentiate this 2 times, suppose I will differentiate with respect to x first. Okay, then see what will happen. This will be dy by dx is equal to cos x. Okay, again differentiate with respect to x. Okay, so what will happen? This will be d2y by dx square is equal to minus sin x. Derivative of cos x is minus sin x. Okay, so but we know this sin x, this value for sin x, what is sin x? Sin x is nothing but what? This from this equation. Okay, this is our equation star. So from star, sin x is nothing but y. So I can write this as minus y. Okay, so d2y by dx square plus y is equal to 0. Okay, so from the function y equal to sin x, what I got? I got the differential equation. Which differential equation? This differential equation. Okay, this means what? This function y equal to sin x is solution of the given differential equation. Okay, I hope it is clear now. What I am trying to tell you is that I took one function y equal to sin x. Okay, and by differentiating it 2 times, what I got? I got this differential equation. This means what? Y equal to sin x is the solution of this given differential equation. Okay, suppose in the second case, suppose I will take another function. Suppose I will take this as y equal to cos x. Okay, so again if I will differentiate this with respect to x, then see what will happen. This will be dy by dx is equal to derivative of cos x is sin x. Okay, and again differentiate with respect to x. Okay, why I am differentiating 2 times? Because the order of this differential equation is 2. Okay, so what we will get? d2y by dx square is equal to derivative of sin x is cos x. Okay, and here derivative of sin x is minus sin x, so derivative of sin x will be minus cos x. Okay, so this is again equal to cos x is nothing but y, so this will be minus y. So from this what I will get? This as d2y by dx square, take it to the LHS, this will be plus y equal to 0. So from this also I got the same differential equation. What it means? It means that this function, our second function y equal to cos x, is also the solution for this differential equation. Okay, now I hope it is clear. Okay, if I will take, suppose I will take the third equation, third function, like if I will take this as y equal to a cos x, where a is arbitrary constant, b sin x. B is also arbitrary constant, means a and b are arbitrary constants. Okay, so suppose I will differentiate this with respect to x. Okay, so differentiate with respect to x. See what will happen. This will be dy by dx is equal to, a is constant, derivative of cos x is minus sin x, plus b, derivative of sin x is cos x. Okay, so again differentiate with respect to x, okay, see what will happen. This will be d2y by dx square is equal to, a, derivative of minus sin x is minus cos x, plus derivative of cos x is minus sin x. Okay, if I'll simplify this, this will be like a cos x, minus sign will be out. Okay, so this will be a cos x plus b sin x. Okay, and this term is again y. Okay, this term is what? This term is given to be y. So this, I will write this as minus y. Okay, so finally in the last step, what I will get? d2y by dx square plus y is equal to 0. So from this function also I got the same differential equation. Okay, so what it means, this third function is also, this is our function, this is also the solution of our differential equation. Okay, so we got three type of solution for the same differential equation. Okay, means what, which one to take now. Okay, and what is the difference between first two solution and the third solution. Okay, so the solution number 1 and 2, that is y equal to sin x and y equal to cos x, are called the simple solutions. Okay, write down here the solution 1 and 2. Okay, that is what, y equal to sin x and y equal to cos x are called simple solution. Okay, but the solution y equal to a cos x plus b sin x is called general solution. This will be called general solution. Now why this will be called general solution? Because it contains some arbitrary constants. Okay, and what are the arbitrary constants? A and b. I can assign any value for a and b. That is why it is called the general solution. Okay, because it involves these terms like a and b, it is called the general solution of the differential equation. And one more thing you can observe here, the number of arbitrary constant, in this case the number of arbitrary constants are, how many arbitrary constants are there? 2. Okay, and also if you'll observe, the order of our differential equation was also 2. Okay, so there is a relation between the number of arbitrary constant and the order of the differential equation. Okay, and this is how we will form the definition for the general solution of the differential equation. Okay, so from this I can write the definition for general solution of differential equation. Okay, so now see this, I will repeat it again. This y equal to sin x and y equal to cos x will not be general solution, because those solution does not contain any arbitrary constant. That is why it is not general solution. But our solution, third solution, y equal to a cos x plus b sin x, will be called general solution, because it involves arbitrary constant. And one relation we have got, and that relation is what? The number of arbitrary constant in the general solution is nothing but the order of the differential equation, and that is what our definition is for the general solution. So what is the definition for the general solution? Okay, so it is again solution, it is also the solution. It is a solution, but what is difference? In which number of arbitrary constants are equal to order of differential equation. So that is the definition for the general solution of the differential equation. Okay, I hope it is clear now. What means solution? What means general solution? Okay, now there exists one more type of solution, that is called the particular solution. Okay, so particular solution. Okay, so obviously the particular solution will be obtained from general solution. Okay, so we'll write it here. Particular solution is obtained from general solution by giving or by assigning particular values to arbitrary constants. Okay, that's when it will be the particular solution. Okay, what it means? Now what we had this differential equation, d2y by dx square plus y equal to 0, and we got the general solution for this differential equation. That was what? Y equal to a cos x plus b sin x is called general solution. Okay, and the general solution will be particular solution. When it will be particular solution? When you will assign particular value to the arbitrary constant. What are arbitrary constant? This a and b. Okay, for example, suppose I will take a equal to 3 and b equal to suppose -2. Okay, so I assigned particular values to constant. So what this will become? This will be y equal to a is 3, so this will be 3 cos x, and b is -2, so this will be -2 sin x. Okay, so this will be called what? Particular solution of that differential equation. Okay, so and also this particular solution will be satisfying this differential equation. You can check it, differentiate this differential equation 2 times, you will get this differential equation. Okay, so in this lecture, in this chapter in fact, we will try and find the solution of different differential equations using different methods. Okay, so in the next lecture we will study how to find the solution of the differential equation. Thank you.